time moved in slow motion during the early days of the universe. Scientists have embarked on a journey to unravel the mysteries of the cosmos, peering into the distant past when the universe was merely 1 billion years old. What they discovered was astounding: things moved in slow motion compared to the present time. This groundbreaking finding supports the renowned physicist Albert Einstein's general theory of relativity, which posits that the universe moved much more slowly in its infancy. The vastness of the universe presents a unique challenge in studying its earliest days. It is akin to looking back in time, as the faint light from the oldest galaxies continues to traverse the cosmos, making its way towards Earth. Scientists rely on this ancient light to gain insights into the early universe, which was shaped by the explosive event known as the Big Bang approximately 13.8 billion years ago. However, peering into this ancient universe is an incredibly difficult task, even with the aid of sophisticated telescopes that observe different wavelengths of light. To overcome this challenge, scientists turn their attention to a celestial phenomenon that acts as a celestial timetable: the quasar. A quasar, a hyperactive supermassive black hole residing at the heart of an early galaxy, shines with such brilliance that it surpasses the luminosity of our own Milky Way galaxy by a staggering 100 times. This exceptional brightness serves as a cosmic clock, enabling researchers to track time across the universe. By observing quasars over time, a team of dedicated astronomers made a remarkable discovery. They observed that as the universe aged, it seemed to speed up. The results of this study, published in the prestigious journal Nature Astronomy, revealed that when looking back to a time when the universe was just over 1 billion years old, time appeared to flow 5 times slower. Lead study author Geraint Lewis, a professor of astrophysics at the University of Sydney's School of Physics and Sydney Institute for Astronomy, stated, "If you were there, in this infant universe, 1 second would seem like 1 second, but from our position, more than 12 billion years into the future, that early time appears to drag." This groundbreaking research sheds light on the expansion of the universe, a phenomenon that has fascinated scientists for decades. The universe is not only expanding but doing so at an accelerated rate, leaving researchers grappling to understand the underlying mechanisms. Unlocking the secrets of the early universe and comprehending its evolution is crucial in tackling these mysteries, and gaining a deeper understanding of our cosmic origins. As Professor Lewis notes, thanks to Einstein, we know that time and space are intertwined. And since the dawn of time in the singularity of the Big Bang, the universe has been expanding. Previously, scientists had relied on supernovas, massive exploding stars, as standard clocks, to track the slow-motion movement of the universe. However, the observations of supernovas were limited to about half the age of the universe, and a new method was needed to delve deeper into the early universe. Quasars emerged as a viable alternative, enabling scientists to roll back the cosmic timeline to just a tenth of the age of the universe. These luminous objects, akin to ongoing firework displays, have now been established as reliable markers of time for the early universe. Working in collaboration, Professor Lewis and Dr. Brendan Brewer from the University of Auckland conducted a meticulous analysis of nearly 200 quasars observed over 2 decades. By combining observations taken at different wavelengths, they standardized the ticking of each quasar, unveiling the expansion of the universe imprinted within them. These results further confirm Einstein's vision of an expanding universe and refute earlier doubts about the true nature of quasars, and the validity of the concept of expanding space. The study of the early universe, with its remarkable time dilation, has propelled us closer to unraveling the mysteries that lie within the cosmic fabric. It is through these extraordinary discoveries that we gain profound insights into the workings of our universe, its origins, and its future. The ancient light traveling across the cosmos serves as a portal, allowing us to witness the slow-motion ballet of the cosmos, reminding us of the vastness and grandeur of the universe we call home.